Hi friends, welcome to Sai Praveen channel. So today in this video we are going to see one more problem on the Thevenins theorem. So this is a circuit which is we are going to find the Thevenins equivalent for the circuit shown in this figure. So for this circuit we are going to find the Thevenins equivalent circuit. Okay, as we all discussed that first thing we are going to find the already the load terminals are open. See A and B. Suppose if you want to connect a load here, we are going to connect the load RL. So here he is not given the load, so we just find our task is to find the equivalent circuit for the below shown network. Okay, first thing what we are going to do, remove the load terminal and find the VOC. So we are going to find the voltage across this open terminal. For that we all know that what is the voltage present across this 50 ohm resistor is the voltage across this open terminal. So for that we write a statement that VTH equal to VOC equal to voltage at 50 ohm resistor. So by using the voltage division rule, so the voltage across the 50 voltage terminal can be used by the following formula. So V50 is equals to Vs, what is the voltage source? 80 into, for what resistor we are going to find the voltage across the element? 50 divided by sum of the resistances. Sum of the resistance means in the case of we are going to find the R equivalent. So see, to find the R equivalent for this case, so what is the thing we are having? See, these two resistors are connected in series. Okay, these two resistors are connected in series and this series resistance is connected with 30 ohm parallel in for 30 ohms. See here 54. Why? Because these two are in series, that's why we are going to sum this one, and this 54 ohms resistance is connected in parallel with this 30 ohm. So we can write 54 is parallel with 30 and then series to this 12. So plus 12. Finally, what is the formula for parallel connections? 54 into 30 divided by 54 plus 30 plus 12. Okay. So after finding this, what is the should be the value? R equivalent is 9.28. Okay, 9.28. Okay, so R equivalent what we are seeing here is 54 into 30 by 54 plus 30 is equals to 19.28 plus 12. Totally, what is the sum of the 19.28 plus 12? It should be the 31.28. So R equivalent equal to 31.28. So finally substitute this 31.28 here. Then what happened? 8 5s are 40. So 400 divided by 31.28. Finally voltage across the 50 ohm resistor is, so by doing the sum for this we get 12.78 volts. So finally we get the VTH. So VTH equal to V open circuit is equals to voltage across the 50 ohm resistor, that is equals to 12.78 volts. So VTH equal to 12.78 volts. This is the Thevenins voltage. And what about the R equivalent? So what is our Thevenins theorem statement? Whatever the voltages sources and current sources present in a linear network, those things are all replaced by a single voltage source. That means VTH within series connected resistance across it, which is known as RTH. So we already find the VTH. What is the VTH? 12.78 volt. What about the RTH? So to find the RTH, we can make all the internal resistances of the sources present in the circuit to 0. What is the internal resistance of this voltage source? Is nothing but short circuit. So what we can do, we just short circuit that voltage source and find the RTH value. Okay, so these are the resistances what we are having here. So 12 ohms, 4 ohms, 50 ohms, 30 ohms. Now this is to find the RTH, we just come from this side. So what are the things we are having? See, 12 ohms and 30 ohms both are connected in parallel. So 12 is parallel to 30, and then this combination is connected in series with the 4 and 54. Okay, so 4 and 50 equal to 54 ohm. This is nothing but RTH. So by solving this, 12 into 30 divided by 42, 12 3s are 360 divided by 42 plus 54. Totally what we get? 360 divided by 42. What is the value? 8.5 plus 54. Finally, what is the thing? We are getting that RTH equal to 62.5 ohms. So RTH equal to 62.5 ohms. So this is the RTH value. So finally 62.5 ohms. So these are the terminals. Now you people can connect whatever the load you want. You just connected across these two terminals, and you people will join into that. Find the response of the load, whatever you want. You can just connect the load resistance here and find the current and voltage across present between these things. Okay friends and students, thanks for watching this video. These things are very useful to you according to the Thevenins theorem. So don't forget to share this video, like this video and comment this video. Do subscribe the channel. Thanks for watching. Thank you.